Hi guys, this is it's a bit of car booty really. Came from the car boot sale, the flea market, yeah, on Sunday. And I normally would do this on a Monday, but I was busy yesterday, and it's now Tuesday. But anyway, a guy had this on his stall. It was just sitting there like that. It wasn't a computer. It was just this, and straight away, as soon as I see this plastic frame, I know what this is. Yeah, and it's a socket 478 Pentium 4, another one. Considering the apparent rarity of these, I certainly find plenty of them. I'm having a bit of a run lately with them. So this one is a Gigabyte GA81RXP, and I put that into eBay to see if any particular value, and I can't actually find anybody selling one of these. It also says on here P4 Titan DDR, yeah. And I look for that and had a little bit more luck maybe. It appears that this board is only, I think it's not an 800 megahertz front side bus, yeah. I think it's 400. I'm sure some of you guys out there will know a lot about this and be able to tell me straight away. Say, hey, Rich, this is this or that. So I don't think it's of as much value as the previous one I had, the Asus, which had 800 megahertz FSB. I think also that one took DDR 400. I think this one might be DDR 233. Is that right? But anyway, there it is. So let's just zoom down on it and you can have a quick look. So a couple of things are apparent straight away with this. One, it's really dirty. This one's a good clean. It's that sort of dust again we get here. A lot of it comes from the Polymer weather that we get. Yeah, we get a lot of this dust on them. And secondly is that we have quite a lot of trashed capacitors here. They're probably all bad. These ones look okay down here. GSC capacitor. So I'll try and see what the rating is of these actually, just so you can have a look. It probably tells you on the other side. A lot of dust. Capacitors by Who Flung Dung. No, sorry, by GSC, whoever they are. T1ND. 3300. 16 volts. I think so. I can't easily see the markings on these guys, but we're definitely going to need to replace these, yeah. But I think the first thing we're going to do with this before any of that is it's going to go in the sink. So the CMOS battery is coming off it, and it's going to go in the sink with the paintbrush and the hand wash and water, yeah, and get a good dry out, and then tomorrow we'll change the capacitors on this one, and then we'll find out exactly what they were, and we'll see what it does once we put new capacitors on it. While I got this, by the way, I also got a graphics card with it. So the guy actually wanted €5. I mean, I picked this up. How much? €5, yeah. And this was lying around with it, and I said, you know, ballet, okay, and Conesta, CCC. So yeah, with this, and he said, yeah. So I didn't tag or, I just asked him to throw this in with it. It's an ATI Rage 128 Pro. I remember these things. I do remember these things from what, around about 2000 or so, I'm guessing. Yeah, 2000 ATI technology. I mean, I had a business building computers back at that time in the UK. Okay, so that's what we have. I don't think these are. I think I had a quick look, about £12. I think this is one of these. This is worth more than I paid for the two. So if just this is working, I'll get my money back and then some. Yeah, if this is working, I'll make a profit. So let's stick it in the sink, and I'll see you all with this on this video soon. But for me, it'll be tomorrow. Right, so here's the motherboard. It's been in the sink with some hand wash and a soft paintbrush, basically. Washing up liquid works well as well, actually. You can use that. And you can see now it's much cleaner. Yeah, this is looking a lot better than it was before. and we can clearly see, you know, the dust has come out of the various slots. CMOS battery's still off at the moment. I need to put that back on. It's a funny motherboard, this. What's all this about here? Hardware Roger, firmware Roger, testing Michael. What's that about? Anybody know what that is about? Yeah, Roger, Mike. I don't know. Interesting board. It's got two IDE here, and it looks like that's another IDE. Oh yeah, two IDE here. There's 4 IDE on this. There's SCSI LED. There's a SCSI somewhere. Can't see a SCSI connector on it. Yeah, that's a funny thing. Okay, so you can clearly see these are the capacitors that have failed. I mean, these two have very much bulged. Those have bulged as well. All these ones down here look physically okay, but we can't say for certain they are okay. These are on the V core supply, I'm pretty sure. One end goes to ground and one goes to a big all this area. So this effectively, this is ground here, yeah, down there, and this is obviously some sort of power plane going into the processor. So I'm pretty sure they're on V core. They're rated. These are 6.3 volt. Yeah. These things are they're obviously they've got a value on them. 2200, 6.3. So what I'm going to do is I'm going to remove these and then perhaps just take a couple of these off as well. And if they test okay, I think I can assume the rest of them are okay as well, because they all seem to be in the same sort of condition. When it comes to recapping motherboards, by the way, if you're new to this, it's boards of this vintage and socket 775 boards similar that have this problem. It's these types of capacitors that fail electrolytics. Yeah. More recent boards, I'll show you. I mean, they work in the same way. Look, you've got input capacitors. These coils, these are your VRMs. There's 3 on this board. Yeah. And they have these type of capacitors, like solid electrolytics or polymer. And this type of capacitor, these don't tend to fail in the same way. So if you've got a board with these sort of capacitors and it's not working, don't think, oh, I need to recap the board. Yeah, it's not an issue in the same way on boards with these sort of capacitors. Yeah, where the recapping comes in is boards with this type. Yeah, again, I just showed you on here input capacitors, inductor coils, MOSFETs in pairs, output capacitors. Yeah, and this is much the same. It looks different, but the big black thing, these are your MOSFETs in pairs. Yeah, these are your inductors. They look different, but they're inductors. Yeah, and then this lot here appears to be your output capacitors. That's how it looks to me. Yeah, so let's take the faulty capacitors off here and let's have a look at them and let's find some replacements. Let's take just a couple of these off as well and see what they're like, and take it from there. So easiest way to change capacitors basically is a soldering iron, yeah, and solder, or leaded solder, bit of flux. So let me show you how I do this. So this is my soldering iron. This is a KSGER, yeah, it's a T12 soldering iron, and believe me, this is the sort of soldering iron you need for this sort of work. I've tried with older type of soldering irons and they're just not up to the job. The thing with these type, and this has a BC3 tip on here, yeah, is that the actual tip, the heater is integral inside that tip. It's not like a tip pushed over a hot heater, yeah. So this will conduct the heat much easily into the end of the soldering bit. And if you try and do what I'm going to show you now and it's not working for you, and you don't have this sort of soldering iron, really that is your problem, yeah, because I struggled with this using the older type soldering iron. I'll show you the older type I used to use and I'll show you the one I have now, and then you'll see. Okay, so these are my two soldering irons I have here. Yeah, let's just zoom that window out a little bit for you, and you can see what we have. Okay. So this ZD916, this is my old soldering iron. I've had it, oh, I don't know, from about 2014, probably about 7 years. I've had a few different. This is an old one from Maplins. Used to be a shop in the UK, yeah, electronic shop. So sadly defunct now. But that's my old one, and this is a 60 watt soldering iron. And you can see I've got it set to 350 degrees, yeah. And this is the T12, the KSG, and I've got it set to 330, okay. And I'll remove some capacitors using this one, yeah. So we'll use this first, and then I'll also try and remove capacitors, the same capacitor next to it with this one, yeah. And you can have a look, and we'll see how well these two work, even though this one is set to a higher temperature, yeah. Let's see. Once I bought this, I found this much easier to do. That's my experience. The good news is these are actually cheaper than these. I mean, this cost me about 50 or 60 pounds in UK, yeah. You know, around maybe 2015 or something like that. This one cost me like €40. No, actually I got this in the UK, it cost me £40, yeah. So it was like 2/3 the price of this one for something that is just far better at doing the job. So you don't need expensive paste and whatever, and there was a JBC soldering irons, yeah, with the JCB soldering irons. You don't need that stuff. I mean, I'm sure those are excellent soldering irons and very good for the job, but you don't need it for this. This will do the job. Okay, let's have a go. Oh, unfortunately, I lost part of the recording there. I thought I'd unpause the video, and I'd actually hit pause. So I've taken these four off. So I'll show you on these ones how I actually do it. In fact, no, there's one more here we can take off. There's this one, yeah. So we'll go for this one, and then we'll go for a few of these down here, yeah. And I'll show you how I'm doing this. So basically, if you turn it over, you can see the two legs. This is the capacitor, yeah. And I get hold of the capacitor with my fingers. So I'm holding it with my fingers. I heat up from this side. I just pull them out. I waggle them a little bit, yeah. Now, in order to do that, the easiest way is to effectively form a solder ball, yeah. So I'm getting a big blob of solder on the end of the tip, and I'm trying to actually bridge the across the capacitor, yeah. I mean, it's not a bridge, but I've got two big blobs of solder on there now. I can now get my own hand under this. I've actually got hold of the capacitor with my fingers, and I can now heat this blob in one go, yeah. So that's heating both pins. Now just waggle the capacitor slightly, and it will come out the board. It's coming, yeah. That's it. So without any strain, that capacitor came out, yeah. That's how I do that. Let's have a look at. Let's take a few of these off as well, on the V-core. These look okay. I just want to test a few of them. If they're all right, I think they'll all be okay. If they look suspect, I'll take the rest off. So again, we get a blob of solder across the two pins. I managed to bridge that one, yeah. Fingers just on the capacitor, yeah. Get the heat in to both. Just give it a few seconds, and I can just take it out like that, yeah. Just like that. So that's how I'm taking these capacitors off. Let's try with the ZD916. This is my old soldering iron, yeah. So let's try with this one, see what this does. It's clean the bit of crap off the tip, yeah. So this one's set to, it's like quite a big chisel size tip on, yeah. Now let's go for the next one down here. So again, we'll get a blob of solder on each end of the capacitor, yeah. And I'll try to heat them both. Yeah, come on. It's not just falling out like the other one did. It came out, but that took a considerable amount of heat more than the other ones, yeah. So yeah, I did it with both of them, but the T12 is the better. And I have seen occasion where this one really does struggle, yeah. Since I bought the T12, I mean, I bought the T12 in 2019, so 5 years after the other one, 2/3 the price. And the only time I've ever used this one since then, apart from today, is when a couple of the wires fell off inside here to the soldering iron tips. I used this one to solder the wires back on this one to repair it. As soon as I repaired it, I went back to using this again. Yeah. So there you go. Okay. So we have some capacitors off the board. The next thing we need to do now is to clean the holes, yeah, where they came out. And there's a few ways of doing this. I'll show you. This is actually probably the most tricky part of the job, yeah. So the first method is to try using desolder braid. Now, you'll probably find that this will clear maybe one hole but not the other, because there's a heavy power plane or there's a heavy ground plane. Yeah, I mean sometimes it's both. So this you can find sometimes won't work. So let's try on this one. Yes, let's go for this capacitor here. Let's zoom it in a little bit as well so you can see what happens. So these are effectively where the capacitor came from. Yeah, we're going to use a little bit of flux. This is NC559ASM flux. Yeah, it's quite a nice liquidy flux to get on there. My solder braid I use is this one now. I was recommended by a guy on the badcaps.net forum, and this is Chemtronics size 4. You can buy this in a tin with 10 of them, which is how I buy them. I get a tin of 10 for about, I think they're about €15 or something. I'd have to check. 15 to 20, something like that. So we can heat up the board and we can get our solder braid on, yeah. But will it desolder it? Well, yeah, that one it did. And you often find that then you come to the other one and it won't, yeah. Okay, that one came off nicely. Solder braid. Let's try another one. Let's go up to the next one. Again, a lot of this depends on your solder braid in particular and your flux, yeah. It's a matter of getting the ingredients right, and I would suggest if you want to buy stuff, go with the ones I use because you can see they working, yeah. You can see this combination is capable of doing the job. Go for this one. So again, now that one didn't come, yeah. And that one didn't come. Let's try adding a bit more leaded solder on them. Yeah, let's go again. Yeah, it got it that time, so adding a bit of leaded solder helps, yeah. Look at this one. No, we didn't get that one. Right. Another technique you can use here. Put some leaded solder back in, yeah. And we can use the hot air. So I take a hot air, yeah, and I heat the area. I'm not trying to melt the solder, I'm just trying to get a decent amount of warmth. I've got the hot air set to 450 centigrade on full pelt, yeah. This is a quick 861 TW, by the way, the hot air. And I'm just trying to, you know, generally get some heat into this area of the board, yeah. Okay, that should be reasonably well heated. So now we come in again with the soldering braid, yeah. Where am I? I'm there. Okay. So while that's hot, again, soldering the braid and soldering iron, yeah. And you can see that's worked. Okay. That's a technique you can use. Other methods of doing this are to use soldering needles. Yeah. These are soldering needles, so they're like a little set of needles. They're about a couple of euros for a whole set of them. Yeah, they're not from AliExpress. Certainly they're not expensive. And these you can effectively push through the board. Yeah, you can push them through the board. I find this not to be as reliable as that hot air method I used. Let's go for this one, yeah, and this time, first of all, let's just try with a little bit of flux. Same as we do the others, yeah, a bit of flux. A bit of soldering braid, yeah. Let's see if we can take it out. See, that one didn't. That again, that one didn't desolder, yeah. So the idea of these soldering needles is that you can stick it into the hole effectively that's clogged up, yeah, and heat it and see if you can push it through. Now personally I find this doesn't work very well on motherboards. It's not doing. You can use the hot air plus the needle, that is more successful generally. Let's just get the hot air, yeah. So we can use this technique. Hot air plus needle, yeah. Let's see if that will go. I'm getting that quite hot now. I don't think that wants to go. Oh yes it did, yeah, okay. So hot air and needle, that's another way you can do it, okay. Yeah, that's clear, yeah. Because that's now hot anyway, I suspect just using the braid on the hot area of the board will do it, yeah. Let's try it. Yeah, see? No, it didn't come. I thought it did, but it didn't. Oh yes, it did, it's just a bit of flux. So you've seen a couple ways of doing that, yeah. And you can see that, you know, with basic tools, I'm not using anything complex here, you can do this, yeah. The other way is to use a desoldering gun, which is this thing, yeah. This has a vacuum pump on it. Okay. With this one, we can just, first of all, I just want to make sure it's not clogged up. Because these things sometimes do clog up, yeah. Yeah, it's not, it's fine, it's not clogged up, yeah. So with this, we'll go on to the next one, yeah, which is here. So this is just a matter of holding it onto the pin, yeah, counting like 3, 4, 5, 6, 7, 8, 9, 10, and pull it. Now you can see that didn't work. Often that does. To get this to work, your best bet is to use a bit of extra solder, yeah. So you come in with a blob of solder onto the hole, yeah. Again, we have to give it a few seconds on there to heat into the board, yeah, and pull the trigger. Did that one clear? No, it didn't. A technique I've seen that never fails is this one. So again, with this, again we'll get a bit of solder. That's a lot of solder, yeah. I'll just remove some of that. That was too much, yeah. Get a bit of solder on there. We'll get the hot air, and we'll use the two together. So, desoldering gun, yeah. Heat the thing with the hot air, and that works, yeah. That method I've never seen fail, even for the most tricky ones. And this is also the quickest way to do the job, yeah, using something like this. Okay, so you've seen how to do that, so I'll just clean up the last few, and then let's have a look at these capacitors and see if they are any good or not. I'll just show you the tools before we do that. One moment. So this is the hot air station I use. It's a Quick 861DW, yeah. Cost me about €220 or something in 2019. I believe there's an ATN862D now, which is at least as good as this, and about €100 cheaper. Yeah, I probably don't need to tell you how good these are. You go and look this up on the internet. But this is considered one of the best of the medium priced hot air stations. Yeah. Or the ATN862D. So that's what we were using there. The desoldering station, by the way, just get the camera stable, is there, yeah. These are made by a number of makes. There's a ZD915 or 917 that looks like that soldering iron but has the desoldering gun, yeah. Pros Kit make one of these. I'm not sure what brand this is. This came from AliExpress and was about €60, yeah. And I would honestly say that if you are serious about this, if you're going to do more than the occasional recap, that is €60 extremely well spent. And I don't believe you'll ever regret buying one if you buy one of these, yeah. I can't recommend it enough. Yeah, it's a little bit of money, but it makes your life so much easier. Yeah, if you can afford it, just buy one. Take the recommendation from me. Yeah. Okay, so that's the capacitors all removed. You've seen what we used to do it. Let's have a look at the capacitors. So we have these capacitors. I mean, the tops, you can see like they're domed, and they look like caked in some sort of grungy dried stuff. So these are faulty. These are visibly faulty capacitors. Yeah. We have 3 of this type, and we have 2 of these, yeah, and they all have the same like convex top. Yeah, those are bad capacitors. We can test them first for capacitance, but the most important thing really for this is ESR. But let's have a look at them. So these are 3,300 microfarad 6.3 volt, yeah, and there's 3 of these, all the same value. Now let's see what they read. So this is the 20,000 microfarad range. Black to negative. Let's get the thing the right way around, yeah. That reads like less than 2,000, like 800 and something, yeah. 1,000, it should be 3,300, yeah. So that's clearly a bad capacitor, yeah. Let's look at the next one. 500 and something, yeah. So I've changed the range to the 2,000 because the reading's so low, yeah. Let's have a look at this one. About 1,000, 1,100, yes. So they are bad. Let's look at these. Choyo, 1,500 16 volt, yeah. These, by the way, 85 105 centigrade working maximum, yeah. Which I think these are also the same. We can have a look. Yeah, 105 centigrade. So that's something else when we change them. The electrolytics will come in 85s and 105s. Yeah, we need to replace these with 105s. Okay, let's have a look at these. That's reading 570, and it should be reading, what was it, 1,500, yeah, so that's bad. This came out with a bit of solder attached to it, not really a problem. That's why it's just kind of like drawing the solder out the hole with the capacitor. Yeah. So again, black to the negative. That's a bad one. Yeah. These are the other 2. I just removed 2. There was quite a row of these. These are Sanyo, which I think are a better capacitor. 1,500, 6.3. Yeah. Let's see how these read. Again, the negative to black. So that reads higher than it's rated, and that is almost certainly a good capacitor. So have a look at this one. Again, negatives to the black. Yeah, higher than it's rated. So the green one's okay, capacitance wise, yeah, and the others are bad. This is my ESR meter. This one, by the way, this came off AliExpress again for like €15 or something. This ESR meter was about €40, but I also have a a cheap one. So let's try both. You can see what sort of result you're going to get. Yeah. So we'll look at these good ones first. With this one, I need to zero it, so I need to connect the two leads together first, yeah, and hit 0 button. Now we can test the capacitor. So let's look at this first one. Again, black to the negative. Yeah. What's the SR? Very, very low, yeah, 0.018. And I'm not shorting the leads, by the way. That's very low SR capacity, that's good, yeah. Let's have a look on this one. Almost 0, yeah, that's very good capacity. Look at these. Going back to the negative. See, that's a lot higher, yeah. It's a lot higher, and it's saying it's good if the capacitance is less than 47 for 25 volts. Basically, the lower the value, the higher the SR would be anyway, yeah. The higher the voltage, the higher the ESR would be anyway, yeah. But that is a bad capacitor. Let's look at the next ones. I thought it might be even worse than that, actually, reading the capacitors. What's this one reading? Yeah, you see how bad that one is? Go for the third one of these and we'll try the other two. And then let's have a look at the cheap ESR meter that I have. Well, it's not really an SR meter as such, it's a component tester. So that's a bit better, but it's still bad, yeah. So that's those. Now let's have a look at these two, see what these are reading. Okay, so that's bad. And the last one. It's bad, yeah. Let's test these on the cheap component analyzer as well. Let's see what that says. Okay, so this is a little component test I bought for about 8. I think it was like, yeah, about €7, €6.50, about $8, yeah. And with this one, basically, you can put the capacitor into the socket. That's the idea, yeah. You put the capacitor into the socket, and you press the test button. Well, first thing you'll notice, it takes a long time, yeah. And it's saying the ESR is 0.21, yeah, and it took a long time to do that, but it's told us, yeah. That's one of the good ones. Let's have a look at one of these bad ones. So these are reading a few ohms, yeah. Let's stick that in there and press the button. Well, it's telling it's a bad capacity. 30 picofarads, it's saying. I wonder if it's not actually in properly. But it's not told us the ESR. Oh, yeah. Okay, so it's telling us, yeah, 806, 2.6. So this thing is definitely telling us that we have bad capacitors. Yeah, that the SR is bad. So yeah, if you're on a budget, this will do the job, you know. But it's measures the SR, but it's not on the SR meter in the sense that this is. Yeah, I mean this in-circuit tester, I use this. Well, for testing in circuits, I use this for such things as finding short-circuit MOSFETs and VRMs, because it picks up the inductors as being resistors, and I can tell which phase has got the short. You can't do that with this. But then this is like, you know, €6.50, and this was about 35 or 40. Okay, so you can see that, yeah. So depending on your budget, you can still test these. Now let's see if we've got some replacement capacitors, and we'll look at those. So these two were good, yeah, and the other 6 or so on the board, how many years? The other 5 on the board, I'm sure are good as well, yeah. These were bad. These are 3306.3s, and I have some replacements here, yeah. So let's have a look at these replacements and see what the ESR is on these, yeah, compared. I mean, the faulty ones, these were reading between about 2 and 4 ohms, yeah. Let's have a look at these. Oh, yeah, give it a few seconds. Right, so let's look at these. See, 0.05, 0.06, that's a good capacitor, yeah. These are good, the low ESR. These are JC Con 105, JC Con 105 degree again, yeah. You see they're the same value. I got these off AliExpress, I bought about 100 of them. They're not the best capacitor in the world, but they got a lot, like about 400 positive reviews, yeah. Yeah, like 0.2, that's nice. And I'm sure they're quite suitable for this. There'll be people probably telling me I should be using better makes than this, but in my experience, I find this does the job, yeah. Look at that one. Really, really low. So, that's some of them, yeah. I mean, I might just dig around and find one or two others that are reading as low as each other, yeah. The other faulty ones are these. So these are the 105 degree, 1500 16 volt, yeah. Now I don't have any 1500 16 volt. I don't keep that value in stock. But what I do have are these. This is a Chong X, 105 degree again. These are 2200 16 volt. You can substitute these for these. Yeah, these are Choyos. You can fit these and replace these. The fact this is a 2200 and this is a 15 really isn't relevant. It'll work just as well, maybe even a bit better than the original. So you can do that. They're not critical as long as they're the suitable voltage. Yeah, and you know they're reasonably close to the value. See what these read. Yeah, 0.06. Slightly lower value than the other 3300s. You expect them to read a little bit lower. Sorry, a little bit higher ESR. Oh, 0.44. So we have some suitable capacitors. So let's fit them on the board and then let's see what happens. So we're ready to put the capacitors back on the board. The important thing now is to make sure you put them in the right way round, yeah? So you'll see they marked like a white and a blue. Normally the white is a negative end. I mean, you can obviously make a note when you take the capacitors out of the board as to whether that is a negative. You know, you'll see if they show you on the capacitors, almost always the stripe is a negative. I mean, if it was otherwise, it would be marked positive, but these days it's the negative. I've seen old vintage capacitors marked with a stripe to the positive, so you know, just keep that in mind. So if you don't know which way they go in, also like you forgot to check, yeah, you think, oh damn, which way did these capacitors go? I forgot to check which way they came out. Yeah, it's very simple to resolve that problem. So all you need to do is take a multimeter on resistance mode, yeah, connect one end to ground like one of these connectors and just have a look to see which end of this goes to ground. You see the white is the ground, yeah, and that other one reads some resistance, yeah. So the white goes to ground and whichever one goes to ground on these is the negative, because these are all positive voltage rails, yeah. Obviously on a negative voltage rail it's the other way around, but you don't have to worry about that on motherboards. These are all positive voltage rails, yeah. Some have a minus 12, but I don't think you'll find electrolytic capacitors on that anyway. Okay, so we know the white's the negative, so the stripe goes to there, yeah. Easiest way is just to look before you take them out, just so you know which way they go, yeah. So the 3300s went 1, 2, 3. That I did notice where they came out from. The best way for that is if you one of these people, you know, you might get interrupted with a job and you can't finish the job. You'll come back and you're thinking, oh god, which ones went where. Best way to stop that happening is to take a photo before you start, or even like write numbers on the top of each one, the faulty ones, and then take a photo, yeah, and then you can see which went where, because you look at the number that you wrote on the faulty ones, yeah, and say, oh, that was number 4, and you can see where it went, yeah. And obviously, if you know that's number 4, you look up the value on it, yeah. But I know the 3,300s all went here, yeah. 1, 2, let's find the other one. This is the 6.3, 3,300. So these all go here. Again, negative to the right, yeah. Sometimes it's easier to put them in one at a time. I've done them all at once, yeah, and I'm just going to now just slightly splay the legs out a little bit so they stay in place, yeah. Push them flat with my finger, yeah, so they're all in place. Let's just zoom back down a little bit and then we'll do a bit of soldering. This is by far the easiest part of the job, yeah. Once you've got the things out and you've cleaned the holes, then soldering them back in is really not an issue, yeah. So normally I'll come into one of the legs, yeah, get some solder on it. There's already flux on it when I desolder it, yeah. Once I've got some blob of solder on one, I then put my finger on the top of the capacitor, warm that again, and then push the capacitor against the board. That's now flat, yeah. And now I know it's flat, I can just put some solder on the other one. Yeah. Some people prefer to cut the legs first. I prefer to solder them first and then cut the legs. That's that one done. I think that's more a matter of personal preference, yeah. So again, I've got some solder on the leg, finger against the capacitor, push it flat against the board with a bit of heat. It's now flat against the board, yeah. You can then straighten the leg up if you like, because it's not going to go anywhere now, yeah. A bit of heat in there. Soldered, yeah. Last one, again, get a finger against the capacitor, push it flat, and then I'll straighten up that leg and solder. Okay, once I've done that, then I just chop the legs. Well, I say some people do it the other way, they prefer to cut the legs short first. I prefer to do it this way. I think this is just, as I say, it's personal choice. If you have think of any good reasons why I should be doing it the other way, post in the comments below, yeah. Let's chat about it, yeah. You can, if you like, once you've just chopped the legs, just give them a final warm if you so want. But I don't think there was really any real advantage to doing this. But you know, this is, again, if this is how you prefer to do it. It gives you a nice rounded end on the soldered joint, but I wouldn't say it actually makes any difference, you know, to whether it's going to work or not. Okay, let's put the last few capacitors on, and then let's test this board. So you can see we now have a very nice set of capacitors on here. Yeah, the board's nice and clean from the going in the sink. So this is ready to test now. So I'll get a processor and I'll you know, basically get a power supply, and let's see what this actually does now. So of course the first thing we need is a CPU, yeah. It's important to know if the CPU you have is actually compatible with the board, because you can't just assume that it is. This one's a Pentium 4 1.7 gigahertz, yeah. And we can have a look on the internet. The board, actually, I thought it was a GA81 RXP. It's actually an 8i RXP, and the reason I realised that is when I tried to find suitable CPU and couldn't actually, you know, find a listing, which was unusual. So the place I normally go, obviously, is Google, and I just put in like 8i XRP CPU support, yeah. And this site's CPU upgrade comes up a lot, and we can see that it works with some Celerons. There's a whole Celeron D's not working, yeah. And Pentium 4s, it works with some, but you see there's a lot it doesn't support, yeah. The main reason being this motherboard is a 400 megahertz front side bus, and some of these processors are 800 megahertz and they're not supported. Whether they actually run but slow, I have no idea. But we can see here 1.7 gigahertz 400 megahertz front side bus. That's the processor I have. There's another 1.7. Mine's one of these. I'm not exactly sure which, but they're both supported, yeah. So we can say that we have a good CPU for the board. Okay, so we've done that. I can't see any other 1.7s. that have got a cross against them. So I'm pretty confident that I have a suitable CPU for it. So we have that. Let's basically connect it up now, with the power supply and a graphics card, and let's see if it actually works. Okay, so to test it, we're going to need a power supply. Another thing to bear in mind with Pentium 4s, the 478s, these processors took a lot more power from the 5-volt rail compared with the 12-volt rail that's used on more modern boards. Yeah, this power supply is an old one, and it's rated 5 volts at 18 amps. Yeah, and then 12 volts at 14. So really, you need to have a power supply of its vintage really to test these. I mean, you can pick one up cheap, it has a 20-way connector, which is just what you want for this, but that's something you're going to need. The other thing, CPU fans. Yeah, the P4s are particular fitting, and really you're going to need to find one from somewhere if you're getting boards like this that are coming with just the board and no heatsink and fan. Yeah, so if you're really getting into doing this thing, I mean, there's definitely good money in this sort of restoration, but bear in mind you'll have to acquire some bits of kit. Maybe find a P4 that's got the right sort of power supply, cooler and fan, and then sell the board on eBay or somewhere. You'll make some money off the board if you got the thing for the right price, and you've now got the bits you need for testing. Yeah. The other thing we're going to need is some DDR4 RAM. I've got a whole selection of it here. Sorry, DDR400, not DDR4, DDR400. Came with a graphics card, but I honestly don't know if this is any good or not. I do have a known working AGP graphics card that actually came with another P4, so we can put that in there. Now you'll find that it won't sit properly now on the desk, yeah, because this will hit the desk. So the easiest way to do this is just use a cardboard box, a motherboard box, yeah. So balance the board on the motherboard box. Let's just do that. Okay, so I've got the board balanced on a motherboard box, so we can now fit that. We'll start off with a known good card. Normally I go with no RAM to start off with, and I want to see if this will bleep when we power it up. So let me just get, I need a switch to switch the start button when I find out where it is on this board. You could short it with a screwdriver, but I just have a switch with a bit of wire on. It's easy, yeah. And I need to find a little speaker with a bleeper, yeah. Here's a front panel connector, I can see it now. So let me get a switch and a little bleeper as well. Okay, I've connected the wires for the on-off switch and the speaker. I had to look up the user manuals a bit. I couldn't quite work it out from the markings on the board. I've put the CMOS battery on, but we need to just check if that's actually any good, which it isn't. Yeah, so we need a CMOS battery for this next thing. Let's just find one of those. Okay, got a CMOS battery. Let's see. Yeah, that looks good. 3.3. When I find a completely drained CMOS battery, I normally then just check the current draw from that on the microamps meter. Yeah, so this meter has microamps. I think this one does as well actually, but the fuse is gone on it. But this is a microamp meter. It's quite likely it's been lying around for a long time, not plugged in. That's why it was flat. But basically, set range to microamps, positive onto the battery, negative against like the little tab, and push the tab back so the current goes through the meter. Yeah, I'm expecting a couple of microamps up to about 10 microamps. Yeah, it might be a bit more on an older board like this. Yeah, 2.35. If you see something like that, you can be confident that the real-time clock's running. Yeah, so this should start up. The other thing we need to test just before we do try and power this up is to see if we've got any shorts from the 12 volts to ground. Yeah, let's see what we've got here. So resistance mode, yeah, not diode test mode, just resistance mode. Negative, and we go into these yellows. Let's see what we've got. Yeah, I see capacitors charging, so that's good. Yeah, if you read a low resistance, maybe like 20 ohms or something, effectively you're probably seeing the resistance of the processor, and it's likely that the high side MOSFETs here are possibly short circuit. So that's something you need to check. Yeah, I've mentioned this on other videos. You know, short circuit MOSFETs and how these circuits work. But that's good. So you don't have to need to worry about that now. But if you don't know about high side MOSFET shorts and 12 volts and V core, it's something to, you know, to look that up and research it a bit. And I say I've done and will do more videos regarding that. Okay, so we're ready to go. We just need the power switched off at the moment. Power to the power supply, and I'm not going to connect to the GPU. In fact, I'm not even going to put the graphics card in. There's no RAM on this, yeah, so it wouldn't give a picture anyway. What I'm interested to know is, does it bleep? Yeah. What I will fit though is my little post analyzer card in one of the PCI slots. Doesn't really matter which one. And that will give me like a code when it boots up. So let me move the camera so you can see that as well. So this is a post analyzer card. They're very cheap. I mean, this one was about €15. It's PCIe and a few other things, but you can get cheap ones of these, you know, and they work fine on PCIe like this and ISA, old motherboards. Some people tell you these are useless. They're not useless at all. They're very useful. The reason people think they're useless is because they say, well, it doesn't give you a code that say, oh, code 15 means change that chip. It doesn't work like that, but it gives you a very good idea of what's going on and if the thing's going to boot. Yeah. I'm expecting, because there's no RAM, this will probably go to C1 or 2A, something like that, and stop and bleep. So power's onto the power supply, power switch, and let's see what it does. It starts, and it's making a bleeping noise, yeah. And C1, can you see it? As I said, it would probably go to C1. C1 is no RAM. Let me make it a little bit bigger. Yeah, C1, E1, yeah. The red light is saying DRAM, yeah. So that's probably bleeping because there's no RAM on here. So let's see if we can find some suitable DIM. And initially, I'll just put one DIM in here and see what happens. Okay, so I have a double-sided and a single-sided one here. I noticed in the manual, this thing, you know, it had various configurations that will work with single or double-sided. But for now, let's just stick one in. If we not get any joy, we can't get the RAM to work, then we need to refer to the user manual, yeah? But we'll put a DIM in there. That's just one of those single-sided. It's a 512 meg. Let's try power that on and see what happens. Yeah, it's making this continual bleep, yeah? It's a bit of a strange bleeping noise, that. Let's try another one. I'm just balancing the board underneath because this box tends to flex, yeah. That seems to like that one, yeah. It's doing something. Let's put the graphics card in it now and see if this is actually going to try and boot. Yeah, so this is just a known good old AGP card covered in paint, actually spray paint. I've got the motherboard that goes with this. Somebody tried to spray paint a beige case silver with everything still inside it. Yeah, didn't stop it working, but it did cover it all in paint. So I keep that as a spare for testing purposes because I know it's a good one. Okay, so let's put the graphics card in there, and let's connect our monitor. Let's see if it actually works now. I'm not sure it is working because this is going back to 0, but I've got the graphics card in. Let's see what it does. Power on, yeah. Don't seem to have I don't have a picture yet, but it's doing something. Let's come back to the DRAM one. No, it's still going. But just switch my monitor to DVI to see if it actually wants to give us a picture or not. DVI input. No, I don't have a picture. And we have a code 7F, which we can have a look to see what that means. May give us some indication of what's happening with this. Let's just switch it back off and try again. Now I've got a monitor already attached to it. Because I've seen some strange things happen in the past, yeah. So let's boot it back up with a monitor attached. Okay, 7F and no picture. That tells us anything useful. Let's have a look at our little book here. Actually, this belongs to my other PC analyzer. I might even try the other one. An extended NMI source enabling is in progress, whatever that supposedly means. Let's just try the other post analyzer as well. I'll just get that out of interest. I actually have a couple more of these things. This one's just PCI, yeah. This one's ISA and PCI. So let's put the just PCI one on it. Let's see, out of interest, if that gives us the same error or anything different. Yeah. Well, it's not bleeping anymore. That's one pretty good sign. Oh, sorry, power switch didn't switch on. See what this one gives us. Now it's bleeped like to say there's no graphics card, yeah. And I believe that was the same code, that's 7F. And this is the one for this manual, by the way. Is it the same code, 7F? Yeah. But this one bleeps now. It bleeped to say there was no graphics card. So, first thought of that is maybe just a bad connection. I'm pretty confident this is a good graphics card. But we can kind of try to set it in and out a few times, yeah. You'll often find with old boards you need to do this a few times to get a connection. If this doesn't help, we'll try another one. I've got another known good one. So just pushing it in and out a number of times, yeah. Go one more time, yeah. So let's push that in and out a few times. Now let's try. I'll leave the analyzer card off this time because I want to see if it bleeps, yeah. Let's have a listen to see what it does. Power on. I have a picture. I have a picture, guys. Okay. So that may effectively fix that. What we'll do is now is we'll just try putting a hard drive on here. Yeah, I've got a hard drive which has XP on it, which is off of P4, so with a bit of luck it might just boot up. Let's give that a go and see what that does. Actually, just before I do that, add the hard drive, I'll just show you what happens with a post analyzer card when it's actually working, yeah. So this is now giving a picture on the screen. Now you just see what this does. Right, the monitor's come on. I've got a picture. It's detecting the processor right, and it's detecting the memory right. Obviously we need to test the DIMM slots later. But it is saying that the processor's changed this CMOS checksum error, and it's asking me to go to the BIOS and save first, yeah. So we'll do that, and then we'll put the hard drive on. It's worth keeping and get your hands on a PS2 keyboard, yeah. Sometimes on these old boards you might have trouble getting to recognise a USB at first. The same applies to the mouse. I've actually got a USB mouse on here at the moment. I've just fitted, but I have got a PS2 mouse, and I do keep that, and sometimes it's useful when you're working on vintage stuff. So that's a couple other things to add to your shopping list, or just keep your eyes open with second-hand stuff, yeah, and see what you can find. Okay, so I've got the keyboard and mouse on. Let's see if we can move this camera so you can actually see the screen, and then we'll have a look at the BIOS settings, and then we'll see if we can load an operating system on this. Okay, so I've positioned the camera. I'm hoping we can see the screen when this powers up, so let's switch it on again, and let's see what we get on the screen. So we get into the BIOS, yeah. Let's get the keyboard here. Okay. Del to enter the BIOS. Del. There we are, we're in, yeah. So I think we just load the BIOS defaults in here. That's the first. Well, let's load the optimized ones. Let's go mad, yeah. So let's load the optimized defaults, and we'll just save that. And now it shouldn't whinge about the CPU being changed, or the CMOS being corrupted or invalid, yeah. See what it does now. It's thinking about it. It's still thinking about it. It's thinking a lot about it. I'm have to be. That's strange. I would have thought that would just boot up. Let me just restart it and see what happens then. Okay, switch it off. Switch it back on again. Yeah, it's booting now. Bit of interference. I think that's coming from that graphics card, which I thought was a good one. Okay, so it's no longer complaining and bitching about the BIOS being corrupted. Yeah, the CMOS settings. So it's looking for hard drives. There's no hard drives on the machine. So now let's add an hard drive, and let's see if we can get this thing to actually boot into Windows XP. Yeah. Yeah, so as I said, it's basically looking for a system disk now. That flickering on the screen, I think maybe coming from this graphics card. I'll try the one in a minute or 5, but let's see what happens if we put a hard drive on here. So this hard drive is an old IDE, 80 gigabytes, yeah. It's got XP on here. This is off. I have a Pentium 4478 test board, the one that's covered in spray paint, yeah. But I use it for testing AGP graphics cards mostly. So maybe this will boot, maybe it'll get into a loop. It depends on the drivers, you know. Sometimes if you put an operating system on off another machine, it'll boot, and sometimes it just doesn't, yeah. So let's just power this on now, and let's see what it thinks. So yeah, we've got a picture coming up. Testing memory. Found the hard drive. I think this is some sort of RAID controller it has built in, this promised technology. I may have to change some BIOS settings to stop it doing this. Again, I just use the defaults, as you can see. Go on. What do you think of that? It did this before, and then it said there was no hard drive. Oh well. No array defined. Press escape. Oh, ignore that. Is it going to boot? Yeah, start Windows normally. Oh, yeah, and then it got blue screened on me. So I think what we need to do with this now, I'm going to try the other graphics card. Interesting, the flashing stops, that flickering of the graphics card stopped at that point. What I'll do is I'll get another hard drive and I'll install XP, or I'll try to install XP on this machine, and then we can come back to it once I've done that. Okay, so what I've actually done is I've just taken another hard drive that happened to have XP on, and just hooked it on here to see if it works. It does, it actually boots. I've changed the graphics card. The known good card I thought wasn't no good off my test rig, it's putting lines on the screen, yeah. The ATI Rage Pro 2 that came 128, sorry, ATI Rage 128 Pro that I got with it doesn't seem to give a picture, yeah. So this is another one I had lying around. I'm not sure exactly what it is. It's nothing amazing, but it's working, yeah. So you can see we have Windows XP on here now. If I just get the right mouse, yeah. I've put a USB in with SDI on Snappy Driver installer, yeah. This is what I use to install drivers. Basically, I have two of these sticks. It's a USB stick. This is a 32 gig, and it works with older boards. And then I've got another one with 64 gig, which is with both 32-bit and 64-bit drivers, and it works on UEFI boards, yeah. But basically, this one will work on the older boards. It's saying it might be compromised with a virus. It's not. It's just as I've put other stuff on it as well, basically, yeah. So we just click on that, and this is very useful bit of software. So it looks at the board and it picks up all the various drivers, yeah, and like it's saying this is available, saying requires one, but it wasn't found in the drivers pack, that particular one. These are saying more updated drivers are available, yeah. But we can certainly we can install all of them, or we can just install the ones that effectively are not there yet, or we can go say create a restore point, yeah, and we can select all of them, and this is selected all the drivers. And now this, if we click on install, we'll install all 8 of these drivers, yeah. So we just hit install here. It's now making a restore point, and then this will work its way through the various drivers, yeah. I'll just let you see it start, and then I can just pause this video. It'll let us finish off, and then once it's installed all the drivers, we'll try and reboot. If it goes wrong because we created a restore point, then basically we can just, you know, boot and just try to load the last known good configuration. Occasionally I've seen it fail and do that, but 9 times out of 10 this just works and it puts all the drivers on the machine for you. Okay, so let that do that, and then let's try it afterwards. See you very soon. I'll just carry on with this a little bit. Yeah, just so you can see this is what it's doing. Yeah, as you can see, it's now installing the chipset, and it will continue to do this automatically. Yeah, so it's called SDI, or Snappy Driver Installer. It's free. It's a very big download, about 16 gigabytes, and you have to get it gives you like a link, and it's some sort of torrent, but it's not illegal. This is perfectly legal software, yeah. So if you haven't got this, I suggest you go and Google, look for Snappy Driver Install. You'll find this extremely useful when you're working on those older hardware. I mean, the other option would be to go on the internet and, you know, effectively find the drivers from the manufacturer, but sometimes you can't do that, so this gets you out of trouble, yeah. Okay, let's let it carry on doing what it's doing. Okay, so it's now working with XP installed and the drivers installed, yeah. I've got 2 gig of RAM in now. I'm using 2 of the slots. You can see here. I tried it with 3 gig and it wasn't working, so I referred to the user manual. It actually tells me that 2 gig as the maximum that this supports, yeah, and it's doing that. So we'll just boot this up into Windows XP now, and we'll have a quick look, and then yeah, I think we can say this one's fully installed. I'd be interested to know if anybody has an idea of the market price for these. An older P4 board, the one I had I think a week or so ago, yeah, last week, supported up to 3 gig of RAM and 800 megahertz. This one has 4 ID connectors, up to 8 hard drives, I'm guessing. Well, I suspect it's not as valuable as the ones which go up to 800 megahertz front side does and 3 gig. I'm not an expert on the value of retro motherboards, but I think one or two you guys probably are. So yeah, answers in the comment below. What would be, you know, the market price for a machine like this? So we're now in Windows. You can see we've got the graphics drivers loaded. We can just have a look at the quick into properties. So we can just see the processor, the RAM, yeah. There we go. Oh, well, it tells you there, in fact. So we can see, if I just make the window a bit bigger, you can see we have 2 gig of RAM there. Yeah. The processor 1.72 gigahertz, Pentium 4, 2 gig of RAM, and the machine seems to be working stable. Okay, so we can call this one restored. It's working, it's nice and clean, it's ready to go. I'll be interested to know what it's worth, yeah. And hope you enjoyed that. Hope you are interested in restoration of these old motherboards. Let's try and keep them out of the landfill, yeah. See you soon, guys, on another video. Ciao for now. Bye.